Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. This is the last concept we're going to do electron placement. We'll practice these and practice everything one time before we move on to our next concept, will be kinetics. I want to take a moment and quickly review over here electron configuration, quantum numbers. So I've got tin and californium. I want you just going to do long method for tin and shortcut for californium. Sorry about the confusion. Do them both long and short method, and after that give me the quantum numbers. So pause the video, work through those. All right, here we go. Take your time. Any questions, let me know. ltswpd@gmail.com. Like, share, subscribe, comment, whatever you want to do. Awesome. All right, here's the answers. That's our long configuration for tin. Shortcut for californium. So last configuration we're looking at is 5p2 for tin and 5f9 for californium. So the quantum numbers there, 510 plus 1/2 for tin, and 53 -2 -1/2 for californium. All right, now last concept we're going to look at is called the Heisenberg uncertainty principle, or should I say Heisenberg, because Dr. Heisenberg, Werner Heisenberg, was a Nazi. Actually, yes, he was. Heisenberg helped to develop, try to work on the Nazi nuclear bomb because of Allied incursion and prevented from getting heavy metal. They never heavy water, not heavy metal, heavy water. They never could quite get it to work. When the war was over, Operation Paperclip, we scooped him up, brought him to the United States. He began to work for us. And Heisenberg came up with a uncertainty principle. It says the relative position of an electron or its velocity be determined by not both. What does that mean? Okay, so an electron, remember Bohr theory says it going round and round and round and round in an orbit. Heisenberg identified that it was going in all different directions inside a specific orbital, and we can either know what it is right now, but we have no idea where it's going to go next, or we know which velocity, what directional vector it's traveling, but we can't know its instantaneous moment because of the fact that it's in constant movement. All right, and the equation there, the delta x, the change in the relative position, multiplied by the change in the mass of the particle multiplied by the velocity, is greater than or equal to Planck's constant over 4 pi. And there's a picture of a younger Dr. Heisenberg. He lived in the United States quite a few years. All right, so that being done, let's look at a problem. Determine the uncertainty of the position of an electron, which is found to be traveling at 4.895 times 10 to the 4th meters per second. So our equation here for Heisenberg, and we're asking for the position. So we're asking to find x. We're not going to worry about delta. All that means is relative change in. So x is greater than or equal to Planck's constant over 4 pi mv. And remember, we need to know the mass of an electron, which is 9.10938.215 times 10 minus 34th kilograms. And neutrons, electron, protons, in case I get funky again. All right, so there's Planck's constant, 4 pi. Just use the pi button on the calculator. The mass we plug in there from an electron, and then the velocity for the problem, 4.895 times 10 to the 4th meters per second. Now I need to get rid of joules. So remember, joule is a kilogram meter squared per second squared. And I want the unit here, let's do it in nanometers. So meters, we're going to convert it to nanometers. We're going to get 1.183 nanometers. All right, let's try another one. Find the uncertain position of an electron traveling at a velocity of 2.118 times 10 to the 5th meters per second. This time I think we're going to do it in angstrom. Let's take a look. So our equation again, solving the same thing. We're looking for x. Mass is the same. It's still an electron. The velocity is listed in the problem. Planck's constant. Plug it in. And then we're going to do angstroms here. So crossing everything else, joules are gone, kilograms are gone, meters, seconds, angstrom, second meter, second, in angstrom, multiply through 6.63 EE minus 34 times 1 EE10 equal divide by 4 equal divide by pi equal divide by 9.10938.215 EE minus 31 equal divide by 2.118 EE5 equal Answer is 2.735 angstroms. And that's correct. All right. Try this one on your own. Find the level of uncertainty of an electron's velocity if the uncertainty of the position is within 2.11 angstroms. Okay, so pause the video, work through it. We're just going to solve for V here. Okay, ready? So our equation, our unknown values, plug them in, get rid of the other values, cross out the units. We're going to end up with 2.74 times 10 to the 5th meters per second. That's our answer. All right, identify the uncertain velocity. Do this one on your own as well. All right. Any questions, let me know. tswpd@gmail.com. Like, share, subscribe, comment, anything you want to do. Ready? There's your work. Oh, back it up. There, I went too far. There we go. And the answer is right there. Awesome. All right, we're done. Any questions, let me know. Take care. God bless. Bye.